We'll just conclude this section by recapping some of the things. So we have talked about temperature, energy, winds, precipitation. So looking at these animations will reinforce some of these ideas in your head. These are very simple climatologies, as we say. So they are looking at, you can see the weeks jumping around here or progressing starting from January, and you can see that it's every week or so. What they have done is take data from 1979 to 2000 and compute the climatology for each week. I think you already learned what it means. So if you take the first week of January for each year from 1979 to 2000 and make the average temperature, that would be the climatology of the first week of January, and similarly you do it for the second week, third week, every week of the year. It gives you a sense of how seasons evolve and how temperatures change with the seasons and why things seem to move north and south. You already know that sun moves north and south. We keep saying sun moves north and south, but actually Earth is going around the sun, and because of the tilt, the energy, we sit and look at the sun from the earth, it looks like sun is going north and south. So it's what you expect in general. So I don't know if I can stop this. Probably not. So these are GIF images which are not really like animations which have a start and end. It just keeps looping through. So here we are coming into June, July, August. So you can see how Indian Ocean is warm. Let's just start here, and then come winter months and everything gets colder in the northern hemisphere when they get dark purple colors here. So now it's winter in the southern hemisphere or Antarctica. Here is the Southern Ocean. You can clearly see how this channel is got these nearly parallel looking temperatures, and you have some warm temperatures in the low latitudes, cold temperatures in the high latitudes, and the warm temperatures spread northward in the boreal summer. You remember boreal means northern hemisphere and austral means the southern hemisphere. So here we are going into spring and summer. Sun is going north to the Tropic of Cancer and then heading south. So you can see as fall and winter come, the purple colors explode on Greenland and Arctic and Siberia, which get very cold, and then it gets into the summer of the northern hemisphere and the winter of southern hemisphere. So you can keep staring at it and see that the entire system moves back and forth. What happens is you have to pay attention if you want to learn more, especially if you're the older kid. Then let's say focus here on Galapagos. Okay, so even though low latitudes are warmer than high latitudes in both hemispheres, there is a difference in the temperatures in the Southern Ocean because it's a channel. You can see that it's remarkably different from the same latitudes here in the northern hemisphere. But even in the tropics, it's not uniformly warm everywhere. Indian Ocean is in general warm throughout the year, but if you look at the Atlantic and Pacific Oceans, look at the Pacific Ocean here. I jumped from the Galapagos back out, but look again, here is the black dot, which is the Galapagos. You can see as the summer months come, the temperatures are colder here. It's around 20 degrees, whereas in the west, around Australia, New Guinea, the Great Barrier Reef, Philippines and so on, it gets warm, 29-30 degrees during the summer months. But these warm temperatures also move back and forth. So as fall comes, you can see they begin to move south. In the boreal fall and winter months, its warm waters are to the south of the equator, and this place gets cold during the summer months, gets flatter and slightly warmer during the spring months, so March, April, May. You can see as March is approaching now, it is getting warmer here, and then again as spring and summer come, it gets colder. You can see cold waters coming all the way up into the deep tropics. I had mentioned Galapagos before. It's famous for its iguanas, its penguins, and its wild biodiversity, the finches and all kinds of things. People go there driving, snorkeling and so on. I had mentioned Darwin sitting there with his Beagle, the ship, for 3 months, having some epiphanies or new thoughts about evolution over time, life, how it evolves and so on. Why is there cold water here? Actually, we already mentioned it. If you remember, again, we have northeast winds coming from the northeast towards the southwest. We have southeast trade winds running into the northeast trade winds, creating this warm band of water which is under the ITCZ, or the Intertropical Convergence Zone. What happens to the water on the equator as the southeast trades push it west, as the northeast trades push it west? Remember that the Coriolis pushes the water to the right of the direction of motion in the northern hemisphere, and the Coriolis pushes the waters to the left of the direction of motion in the southern hemisphere or south of the equator. So if you are trying to push water to the west on the equator, just to the north, water will be pushed to the north, to the right, and just to the south of the equator it will be pushed south, away from the equator, to the left. So you're moving water away from the equator, which means cold water from below is going to come up, and this is called upwelling, and this is why you have cold waters here. And deep cold waters have nutrients that come up, and they produce a lot of nutrients for phytoplankton. There is a big bloom of phytoplankton that happens here. I think I should put that animation back of the vegetation, which I will do. We'll look at chlorophyll, and you'll see that chlorophyll also explodes here, and it is one of the most productive open ocean region as well. You can see the Gulf of Mexico is warm. You can see that during the boreal summer months, when there is strong monsoon, Bay of Bengal tends to be warmer, as you will see soon here, May, June, July. So you can see the Arabian Sea is cold with the Somali current. Bay of Bengal has more rain, Arabian Sea has more evaporation, India gets rain. We'll see the rain in a minute, and so on and so forth. Okay, so we are repeating what we said more by looking at the animation. So you can sit and stare at this animation and look at all the nice features. One of the more interesting feature, which is a bit more complicated for the young kids, is this region here in the Atlantic will be warmer than the same latitude in the Pacific Ocean, and there are good reasons because how the Gulf Stream behaves and how the Kuroshio behaves here, and for the same reason the regions over Canada here will be much colder than the regions over here in Europe. You can see that as the winter comes, very cold temperatures sweep down from the poles towards low latitudes here over Canada, whereas the warm Gulf Stream comes in here. These regions remain much warmer during the fall and winter months, which also means there will be more snow and ice falling here, whereas there will be drizzle and rain falling here. And so on. And of course you see that the Himalayas are very cold. Tibetan plateau over here gets, because its altitude is high, gets very cold. Sahara is a desert, so it gets very warm, and the oceans have more uniform temperatures. Because oceans have high heat capacity, they do not have a huge seasonal or daily time scale changes as compared to land regions. Because land regions have low heat capacity, they will warm up and cool down quite a bit. So if you compare the nighttime temperature and daytime temperature over the oceans and lands will have a huge range from daytime to nighttime, whereas ocean will have a smaller range. Similarly, the seasonal changes also can be much smaller over the ocean compared to land. Okay, so these are simple points we already had said, but it's nice to recap them with this animation. So we'll come back and look at the animation of the vegetation quickly, just to repeat some of the points in this context again. Okay, see you in the next podcast then.